Once upon a time, in a vast and mysterious universe, there was a seemingly endless expanse of stars, planets, and galaxies. Among them, the 8 planets of our own solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, were some of the most fascinating and awe-inspiring. Mercury, the closest planet to the Sun, was a scorched and barren world with a heavily cratered surface. Venus, on the other hand, was a sweltering hellscape with a thick, toxic atmosphere and a surface hot enough to melt lead. Earth, of course, was our own home, a verdant and diverse world teeming with life. Mars, the red planet, was a dusty and desolate landscape that once held vast oceans and rivers, but now was home to only the occasional dust storm. Beyond Mars lay the gas giants, Jupiter, Saturn, Uranus, and Neptune, 4 massive worlds of swirling gases and icy moons. Jupiter, the largest planet in the solar system, was a behemoth that could fit all the other planets inside it. Its great red spot, a gigantic storm that has raged for centuries, was visible even from Earth. Saturn, with its iconic rings, was perhaps the most recognizable planet in the solar system. Uranus and Neptune, while less well known, were no less fascinating, with their bizarre magnetic fields and strange, icy moons. As humanity's understanding of the universe grew, so did our fascination with the planets of our solar system. We sent probes and rovers to explore their surfaces, and orbiters to study their atmospheres. We learned about the violent history of the early solar system, when planets collided and asteroids rained down on the inner planets. We marveled at the diversity of the moons that orbited the gas giants, from the icy geysers of Enceladus to the methane lakes of Titan. But as we looked beyond our own solar system, we began to realize that the 8 planets we knew so well were just a tiny fraction of the billions of planets that likely existed in the Milky Way galaxy alone. We discovered exoplanets, planets that orbited stars other than our Sun, and found that they came in all shapes and sizes, from rocky worlds like Earth to gas giants like Jupiter, and even stranger, more exotic worlds that we could barely imagine. And so the story of space and its planets continues, as humanity pushes ever farther out into the universe, seeking to understand the vast and mysterious cosmos that surrounds us. Who knows what wonders we will discover in the years and centuries to come. Predicting the exact progress humanity will make in space in the next 10 years is a challenging task, as there are many variables and factors that could impact the pace and direction of space exploration. However, based on current trends and ongoing developments, it's possible to make some educated guesses about what we can expect to see in the coming decade. One area where we're likely to see significant progress is in the field of commercial spaceflight. Private companies like SpaceX, Blue Origin, and Virgin Galactic are already making strides in launching reusable rockets and spacecraft, with the goal of reducing the cost of space travel and making it more accessible to people outside of government agencies. In the next 10 years, we may see more private space companies emerge, and perhaps even the beginning of space tourism as a viable industry. Another area where we're likely to see progress is in the exploration of the Moon and Mars. NASA's Artemis program aims to return humans to the Moon by 2024, and establish a sustainable presence there by the end of the decade. Private companies like SpaceX and Blue Origin are also working on lunar missions, with the goal of eventually using the Moon as a jumping-off point for missions to Mars. In the next 10 years, we may see more robotic and human missions to both the Moon and Mars, with a focus on establishing long-term habitats and conducting scientific research. Advances in technology will also likely continue to drive progress in space exploration over the next decade. For example, developments in artificial intelligence and machine learning could enable more sophisticated and autonomous spacecraft and robots, making it easier to explore and study planets and moons that are too dangerous or difficult for humans to visit directly. In addition, new materials and propulsion systems could make spacecraft faster, lighter, and more efficient, enabling longer and more ambitious missions. Finally, we may see progress in the search for extraterrestrial life over the next 10 years. With new telescopes and observatories coming online, scientists will be able to study exoplanets and their atmospheres in more detail, looking for signs of habitability and potential biosignatures. The discovery of even simple forms of life beyond Earth would be a major milestone for humanity and could have profound implications for our understanding of the universe and our place within it. Of course, these are just a few possible examples of the progress we may see in space exploration over the next 10 years. There are sure to be many surprises, challenges, and breakthroughs along the way, as humanity continues to push the boundaries of what's possible in space. Deep space refers to the vast and mostly empty expanse of the universe beyond our own solar system. Scientists have been studying deep space for decades using telescopes, space probes, and other instruments to learn more about the cosmos and the many mysteries it contains. One of the most exciting discoveries in deep space in recent years has been the detection of exoplanets, planets that orbit stars other than our own Sun. Thanks to advances in telescope technology, scientists have identified thousands of exoplanets in the past decade alone, ranging from small, rocky worlds to massive gas giants. In addition to exoplanets, scientists have also been studying other phenomena in deep space, such as black holes, dark matter, and cosmic rays. Black holes are incredibly dense regions of space where the gravitational pull is so strong that nothing, not even light, can escape. By observing the effects of black holes on nearby matter, scientists have been able to learn more about the physics of the universe. Dark matter is another mysterious substance that scientists believe makes up a significant portion of the universe. Unlike normal matter, which can be observed and interacted with, dark matter does not emit light or interact with other matter through electromagnetic forces. Its presence can only be inferred through its gravitational effects on visible matter. Cosmic rays, on the other hand, are high-energy particles that originate from beyond our solar system. Scientists believe that cosmic rays are produced by supernovae, the explosions of dying stars, and other high-energy events in the universe. By studying these particles, scientists hope to learn more about the origins and evolution of the universe. Another exciting area of research in deep space is the search for extraterrestrial life. While scientists have yet to find conclusive evidence of life beyond Earth, they have discovered many planets and moons that could potentially harbor life, such as Mars, Europa, and Enceladus. As technology continues to improve, scientists hope to be able to detect biosignatures, or signs of life, on these and other worlds. Overall, deep space is a rich and fascinating area of study that holds many mysteries and opportunities for discovery. While much remains to be learned, scientists are making remarkable progress in their quest to understand the universe and our place within it. One area where we may see technological advancements in space development is in propulsion systems. As we continue to explore and establish a presence in deep space, we will need more efficient and advanced propulsion technologies to travel greater distances and achieve higher speeds. Scientists are exploring a variety of propulsion methods, including nuclear propulsion, ion engines, and antimatter propulsion, which could potentially enable faster and more efficient space travel. Another area where we may see technological breakthroughs is in materials science. The harsh and extreme conditions of space pose many challenges for spacecraft and other equipment, which must be able to withstand extreme temperatures, radiation, and other hazards. Scientists are researching new materials and composites that could be more durable, lightweight, and resistant to damage from space environments. Additionally, advances in artificial intelligence and robotics could play a significant role in space development. As we explore more remote and dangerous locations in space, robots and autonomous systems will become increasingly important for conducting scientific research, performing maintenance tasks, and even building infrastructure. More sophisticated and autonomous robots could enable us to explore deeper into space and collect more data about the universe. Finally, there may be breakthroughs in the development of space-based power generation technologies. As we seek to establish long-term habitats and colonies in space, we will need a reliable source of energy to power our equipment and sustain human life. Solar power is currently the most widely used method of space-based power generation, but scientists are also exploring other methods such as nuclear power, which could potentially provide more energy in less space. Of course, these are just a few possible examples of the technological advancements that we may see in space development in the future. As research and development continue, we can expect to see new breakthroughs and innovations that will enable us to explore deeper into space and unlock the mysteries of the universe.